Hello everyone and welcome to our 11.7a notes on surface area of pyramids and cones. And yesterday we did surface area of prisms and cylinders, which each had two bases. Today we're going to look at pyramids and cones, which each have one base. One base, one base. So each of these is going to have exactly one base. And so how does that affect our formula? Well, yesterday was LA plus 2B. Today is going to be very similar, but it's going to be LA plus 1B since it's just one base on each of these shapes. So first, let's look at pyramids. Go ahead and write down your formula for the surface area of a pyramid. It's going to be LA plus B, which is the walls plus the base. Okay. What is different about this shape? Well, for a pyramid, we know that instead of having rectangular walls, I'm going to have triangular walls. So when I unfold this shape, here's my base. It looks like this is going to be a square base because it has 4 congruence marks. So there's my square base. And then there's my 4 walls. Those 4 walls are made up of triangles. And so when we find the area of those the walls, we know that something's going to be divided by 2. So that is where this comes from. It is going to be your perimeter times your slant height divided by 2 since those are triangles. And then we're going to add the base to that. So that is going to be my surface area formula for a pyramid. It does give us a note over here. It just says make sure to use the slant height, which is L, for each triangle's area, because we're finding the height of those walls. Well, the height of those walls is going to be slanted when you fold it in, and so that is going to be this piece right here. This would be a slant height. It's the height of that wall, and then this would be a slant height as well. So it's going to be slanted when you actually fold it up. So we want our slanted height, P times L divided by 2. If you're not given the slant height, you're going to use the Pythagorean theorem to find the slant height. So if you're given a height, so let me just draw one in. If we are giving an interior height, you could use Pythagorean theorem to say h squared plus a squared equals L squared. Okay. So we will look at a few examples of those. We don't want the interior height, the internal height. That's going to be for volume. We want the slanted height of the walls since surface area goes with walls. Okay, so let's do a few problems. Solve for the indicated values, round to the nearest tenth if necessary. So let's color code this first. This looks like it's going to be a square pyramid because it's a 6 by 6, and we're going to go ahead and write out our formula. I'm going to do surface area equals my lateral area plus just one of the bases, since there's only one base. What is my formula for the lateral area? It's going to be P times L divided by 2 plus the area of the base. So we need the perimeter of the base first. P stands for perimeter of the base. So what is my perimeter of the base going to be? That is going to be 6 times 4. Perimeter is going to be equal to 6 plus 6 plus 6 plus 6, or 6 times 4, either way. So what does that give me? My perimeter is going to be 24. What is my slanted height of those walls? The slanted height of those walls is going to be 10, so that's my L. And we want to multiply those together and divide by 2. And then what we're going to do is find the area of the base. Well, what is the area of the base? The area of the base is a square, so it's going to be a 6 by 6, which is going to be 36 feet squared. Okay. So we've got my walls plus one base. So what is 24 times 10? We know that that's going to give me 240. We're going to divide by 2. So for my walls, we've got a surface area of 120 for my walls plus 36. So my lateral area, just those triangles, is 120 feet squared of surface area. And then my total surface area of the entire shape, when I actually add my base in, is going to be 156 feet squared. So just those 4 triangles, just those 4 triangular walls is 120 feet squared for the lateral area, but that gives me 156 feet squared when I add that one base to it. All right, we have another square pyramid here. The difference on this shape is that I do not have my slanted height, so it's going to be LA plus B. We know that the lateral area formula is P times L divided by 2 plus my base. Unfortunately, I do not have my slanted height. So here's my base. Let's go ahead and color it, and then it's a square. Okay, and then here is my height that's given is my internal height. We need our slanted height, which is the height of this triangular wall. So that's going to be a right angle right here. So it says to use the Pythagorean theorem. And so what I'm going to do is I'm going to draw in halfway across this square. Halfway across this square is going to give me a side length of 6 inches right here, because that's half of 12. And then this height that's given is 8, so I get to use Pythagorean theorem. 8 squared plus 6 squared is going to be equal to L squared, so we're going to use Pythagorean theorem. When I type in 8 squared plus 6 squared, we know that's a multiple of a 3, 4, 5, so L squared is equal to 100. So L is going to be equal to the square root of 100, so my slant height is going to be equal to 10. So this slant height is going to be equal to 10 inches. So now I have my slant height. So let's go ahead and find my perimeter. What is my perimeter? My perimeter is going to be the perimeter of the base, so 12 plus 12 plus 12 plus 12, or 12 times 4, either way. So that's going to give me a perimeter of 48. What did I just find my slant height was? My slant height is 10. We're going to multiply those together and divide by 2, and then add in an area of the base. Well, this base is a square, so what is 12 times 12? That gives me 144. Okay, so we're just going to go ahead and multiply that out. We're going to get 480 divided by 2 is going to give me lateral area of 240, and then the base is 144. So lateral area is 240 inches squared. When I add 144 to that, I'm going to have a total surface area of 384 inches squared. So there is my lateral area. There is my total surface area when I add in that base. So that one was a little bit harder just because we were not given the slant height. Okay. We have another one of these problems. It is a square pyramid. Now, they did not tell me that this one's a square, so I'm going to add the markings so that you know. I don't know if you can see them very well. That is going to be a square base. So it's either going to have the markings or I will tell you. So there's my square base. I'm given my internal height. So again, I'm going to have to find my slanted height. So that internal height, I'm going to move the 10 because sometimes that confuses me when it has an arrow. I'm going to move the 10 meters to right here. There's my internal height. That makes this part of the right triangle 2 meters because it's going to be half of the 4. And I'm going to have to find my slanted height, which goes from here to here. So I'm going to put an L on that. So that's going to be 10 squared plus 2 squared equals L squared. This one I do not believe is going to give me a perfect square. When I do a 10 squared plus 2 squared, it gives me 104. So L squared is going to be equal to 104. So L is going to be equal to the square root of 104. So L is going to be equal to the square root of 104. So we can round that in a minute. It's about 10.2, but we're going to wait and round till the end. And so when I go to find my surface area, it's going to be equal to my lateral area plus my base. Of course, my lateral area is going to be equal to P times L divided by 2 plus the area of that base. We just found our slanted height. What's my perimeter, though? Let's see, perimeter is the perimeter of the base. So 4 plus 4 plus 4 plus 4 is going to give me a perimeter of 16 times my slant height of 104. That's going to be divided by 2. And then the area of the base is going to be a 4 by 4 square, which is 16. So if I wanted to wait and round to the very end, I could. I could just leave it as 16 times root 104 over 2. But they do tell me to round my answers. And so the 16 times the square root of 104 divided by 2 gives me, when I round it, gives me about 81.6 meters squared. I'm going to go ahead and add 16 to that number that's in my calculator so that my surface area is only rounded once. It's about 97.6 meters squared of total surface area when I add in that base. So there's my walls, and then there is, whenever I add in my base, that's the total surface area. Okay, so those are a few pyramids. We're going to keep going and do a few more, and then we'll look at cones. Okay, so here is let's go ahead and highlight my base. This is a square pyramid. They give you the slanted height, thankfully. So on this one's going to be way easier. I don't actually have to find my slant height. Surface area equals my walls plus one base, not two bases, but one. Make sure I did that earlier too. Yes, just one base. That's why I always write this step, is it just kind of helps me think through the formula. I have the walls plus one base. Well, what are my walls? It's going to be P times L divided by 2 plus my base. So what is my perimeter going to be of the base? 9 plus 9 plus 9 plus 9. That's going to be 9 times 4, which is 36. There's my perimeter. My slant height is given. It's 11. I'm going to multiply those, divide by 2. And then what is my area of that square? I'm going to add 81 at the end. So 36 times 11 divided by 2 gives me 198 plus 81. So my lateral area is 198 inches squared. When I add 81 to that, to those walls, that one base, I get 279 inches squared of surface area on this whole shape. So here are my walls, and then when I added in the 81 inches squared of base, that gives me 279 total for the surface area. All right, here is a base. This is a square base. Now on this one, they give you an internal height. That's going to be what we use for the volume. So we are going to have to find our slanted height, which is this piece. So we draw in here. This is going to be half of 7, which is 3.5. And we want to find our slanted height. So that's going to be 12 squared plus 3.5 squared equals our slanted height squared, Pythagorean theorem. So this is going to give me 156.25. So L is going to be equal to the square root of 156.25. Okay, so we go to find our surface area. I'm going to go ahead and skip ahead here. It's going to be P times L divided by 2 plus our base. So my perimeter is going to be 7 plus 7 plus 7 plus 7 on that squared. 7 times 4 is going to give me 28. So it's going to be 28 times my slant height, which is 156.25. I'm going to multiply those together, and I'm going to divide by 2, and I'm going to add the area of the base. Well, what is a 7 by 7 area going to give me? It's going to give me 49 total. So let's type this in. It doesn't want me to round it. 28 times root 156.25 divided by 2 is going to give me 175. So that's going to be 175 plus 49. So 175 feet squared is my lateral area. That's just the walls. How do I find my surface area? I add 49 to it for that base. That is 224 feet squared of total surface area on this shape with all 4 walls and the base. All right. The next problem is just like the last few we did, so for the purposes of time, I'm going to skip that one, and I can work that with y'all later if you would like to see that one again. So let's move on to cones. Cones, it's still going to be LA plus B, walls plus base. But if you think about the walls of this shape, when you unwrap a cone, what shape do you have as the base? My base is going to be a circle. So in my formula, pi r squared is the base. There's only one of those. How do you find the walls? So I'm going to color code that to be blue. How do you find the walls? To find the walls of that shape when it's unwrapped, that is going to be a sector of a circle. So to find that, you're going to do pi times r times L. So we do need our slant height here. We are going to need our slanted height. So this piece will be my slanted height. If they give you this one, that's your interior internal height. We don't need that one. We'll need that for volume later. So we need our slanted height. So the two things you need are you need your radius and you need your slant height. So pi RL plus pi r squared is going to be our formula. Pi RL plus pi r squared. So here's the pi r squared part. Oops, sorry, y'all. Here's the pi r squared part to find the area of that circle. Here's the pi RL part, and you're just going to add those together. That's the walls plus the base. Again, it says make sure to use the slanted height for the area of the curved section. If it's not given, you're going to use the Pythagorean theorem. So for these problems, since these have pi in them, we're going to leave them in terms of pi. So surface area equals LA plus 2B. There's just one base. So that's going to be pi RL plus pi r squared. So the only two things we need are our slanted height, which is this one, that's 13. That is slanted. The 13 is talking about that slanted piece. And then we need our radius. So what is my radius? My radius in this picture is 5. So I'm going to plug those in. My surface area is going to be equal to pi times 5 times my slanted height, which is 13. So I'm going to do that in pink just so it kind of stands out, plus pi times 5 squared. So we want this in terms of pi, so we're going to go ahead and multiply these out. What is 13 times 5? 13 times 5 is going to give me 65 pi here for my lateral area. So that's going to be 65 pi meters squared. And then I have to add the area of the base to that, which is 25 pi. So what is 65 plus 25? That is going to give me a total surface area of 90 pi meters squared for this cone. So 65 pi meters squared is the walls. And then when you add in the area of the base, it's going to give me a total of 90 pi meters squared for the surface area of this cone. So if you were to unwrap this shape, that is exactly how much material you would need to build the same shape. Okay, so we're working with another cone in this next picture. I have my radius, it's 12. And then I have my internal height. I don't need my internal height, I need my slanted height. So how do I use this to find my slanted height? Again, what I like to do is scribble that out. The 16 centimeters makes it look like it's on the outside. It's not, it's right here. And so I'm going to use Pythagorean theorem to find my slanted height. So that's going to be, when I do that, that's going to be 16 squared plus 12 squared equals L squared. So when you type in 16 squared plus 12 squared, you're going to get 400. And so it's going to be equal to the square root of 400. What is the square root of 400? Since that's a perfect square, that is going to give me 20 for my slanted height. So L is equal to 20 centimeters. Okay. So that helps me out when I get to here. We're doing our pi RL plus pi r squared. So pi times 12 times 20 plus pi r squared. Pi 12 squared. And so when I do 12 times 20, that's going to give me 240 pi. That's just for my walls. Centimeters squared. And then I need to add in the 144 pi for my base. So plus 144. That is going to give me a total of 384 pi centimeters squared. And if they wanted you to round that to the nearest tenth, we would actually just type in the pi symbol. You'd do 384 times pi. All right, this next one does not have a picture, so we're going to come back to that one. We'll do those last. Let's go to one that gives you the diameter. So this one we do have our slanted height, thankfully. There's my L. You can go ahead and label that if you'd like. There's my L. But then it doesn't give me a radius. It gives me 20 as the diameter. So what is my radius going to be? My radius is going to be 10. And so when I go to plug that into the formula, surface area equals pi RL plus pi r squared. Just make sure you plug in the right thing. That's going to be pi times 10 times my slanted height, which is 22.4. And we want to add the area of the base, which is going to be pi times 10 squared. So 10 times 22.4 is, of course, going to give me 224 pi for my walls. That's my walls unwrapped, 224 pi. But then I have to add in the area of the base. So that's going to be 100 pi. So what is 224 plus 100? That's going to give me 324 pi miles squared. So there's the walls, and there's the entire surface area. All right? This next one is turned sideways, but don't let that throw you off. Here's my circle. That's my base. There's my radius. Now, I do have my internal height given. We're going to need that later when we do volume, but this is pointing. I'm going to scribble it out. The 16 meters is pointing right here. So we're going to have to use Pythagorean theorem to find my slanted height. And so you're going to do 16 squared plus 8 squared equals my L squared. 16 squared plus 8 squared is 320. So my L is going to be equal to the square root of 320. Okay? So when we go to plug that in, it's going to be surface area equals pi RL plus pi r squared. We have both things we need now. It's going to be pi times 8 times the square root of 320. So let my calculator do that in a minute. Plus pi times 8 squared. So 8 times the square root of 320. It does want me to round it. This is going to be about 143.1 pi. That's meters squared. So wait and round it once at the very, very end. So that's about 143.1 pi. And then we're going to add to that 64 pi. What do I get when I round at the very, very end? That's about 207.1 pi meters squared for my total surface area. Okay. All right, let's do one of these where you actually have to draw it. It says a cone, so let's draw a cone. I always start with my circle, and then I have it coming to a point. It has a diameter of 6 centimeters. So if its diameter is 6, what is its radius going to be? If diameter is equal to 6, then the radius is going to be equal to 3. I'm only going to put in the radius because I feel like that will help me a little bit more because I need the radius, not the diameter. And this cone has a height of 15 centimeters. Now, it doesn't say slant height. It has a height of 15, so that's internal. So we're going to have to find our slant height using Pythagorean theorem. So that's going to be 15 squared plus 3 squared equals L squared. So 15 squared plus 3 squared is going to give me the square root of 234 for my L. I do not believe that that is a perfect square, so I'm just going to leave it like that. And now I get to plug these things in. So surface area equals, we're going to do pi RL, so pi times 3 times root 234. Again, we'll let our calculator do that work in a minute. Times, or plus, my area of the base, pi r squared, so pi times 3 squared. So what is 3 square root of 234 times pi? That is going to give me, I'm going to leave it in terms of pi, so that's going to give me about 45.9 pi. So that is going to be 45.9 pi centimeters squared. And then I want to add to that 9 pi for the area of the base. So plus 9. Again, we're going to type that into our calculator and round at the very, very end. So 54.9 pi centimeters squared of surface area total. And then the walls were just 45.9 pi centimeters squared. All right, the last one, a cone has a radius. Again, we're going to draw this picture. So if in doubt, draw it out. Draw the circle. Have it coming to a point. This one should be a little bit easier. A cone has a radius of 12, so there's my radius of 12 centimeters, and a height that is 3 less than 2 times the radius. Okay, so not quite so easy on this one. A cone has a radius of 12 centimeters and a height that is 3 less than 2 times the radius. So 3 less than 2 times the radius. So what is that going to give me? When I do this, I might save this for when I come back, but whenever we have our radius that is 12, so I'm going to highlight this. It has a height, so here's my height, that is 3 less than 2 times the radius. So 2 times r minus 3 is going to give me this height. So let's plug that in. What is my radius? Height equals 2 times 12 minus 3. So that's going to be 24 minus 3. That is going to give me a height of, I'm going to do this in red. It's going to give me an internal height of 21. If that is 21, this takes it a little bit harder because we still have to find our slanted height. So I'm going to use Pythagorean theorem. That's going to be 21 squared plus 12 squared equals L squared. Okay? And so how do we find our L? We do 21 squared plus 12 squared. And so L would be equal to the square root of 585. And then you would just do this just like normal. So your surface area would be equal to pi RL. So pi times 12 times root 585. Plus pi r squared. So when you do 12 square root of 585, that is going to be about 290.2 pi centimeters squared. And then, so that's 290.2 pi. What are we going to add to that? We're going to add to that 144 pi. So when we add 144 to that, when we round at the very, very end, we get about 434.2 pi centimeters squared of surface area. So that one was quite a bit harder. We can do that together in class one day. We can do another one like that. So it just gives you this expression. This is the only thing that makes it a little bit harder. I was making sure it gave us our height, not our slant height. It gives you a height that is 3 less than 2 times, so 3 less minus 3, then 2 times the radius. And so we just plugged in our radius that was given. So that's a challenge question for sure. So your practice problems are on the back, and we will check those in class tomorrow. This is the surface area of pyramids and cones.